Hello, this is Christian Allen, and today I'm going to be walking you through how you can create an interactive 3D map using Unreal 4 using your environment rather than widgets or something like Scaleform. When we started on Epsilon, really the only two people that were creating content for the game was myself and our environment artist. Because we didn't have any experience creating UI through things like Scaleform, we decided to utilize the actual world environment to create a map. Here you can see our interactive map. Um, in other videos linked below, I go through the details of all the different elements of it. But this is how the player pre-plans their missions by placing waypoints, looking at security cameras, that they can try to find enemies and tag enemies. And there's a lot of different functionality in this map. But what I want to focus on is how this is constructed in game. One of the important things for our game is that this map be interactive, be live, be updated live. And so here I am just playing an editor. I can see I have the game running. And what I'm going to do is I'm going to go ahead and eject from the pawn. Well, actually, first I'm going to jump into the level. It's a fancy new shotgun. But here I am in the space, and I can bring up the map and I can interact with it, do all the things that I need to do. But what I'm going to do, just to give you a behind the scenes, is I'm going to eject from the player pawn. Eject here. And kind of show you what's really going on. So this is our play space, and it is quite large. I'm going to fly out of it here. But what we have happening is way over here. So back over there, that's our level where I just was. And way over here is our actual planning map. And as I fly around, you can see this is actually a 3D model of the map. And way up above here, we have our camera that is actually an actor in and of itself. And it lives up here and basically displays the various elements in the map. Now, what's interesting about these different elements is that they are tied to actors in the levels. They're not statically placed here in the space. And so these actors are updated in real time. So here we have door locks. Those are actually static meshes that are attached to the doors in the level. And then through the blueprint system, I detect what floor they're on through defaults that are set in the actor. And it teleports and updates these lock icons in the space. So as the player unlocks them using either manually or through a security system interface, they're unlocked. So that's how our maps are constructed. And one of the interesting things, I'm going to stop simulating here. And I'm going to open up this camera actor and take a look at it. So this is the blueprint script for the camera actor. We have one of these planning cameras in each level. And it does a few things. One, it displays the map. Um, and it tells what level that you want to interact with by clicking on the widget that's attached to it. And then we have all these different variables that we use to track where the camera needs to be at any one time. So we have the different distances from our floors. And on this level, we have 3 floors, and we support up to 4. And then it moves itself when it's activated to go to different floors based on these variable distances that we set. We try to keep those consistent per level, so it's always the same amount. But we do keep them as variables in the camera actor so that on a per level basis we can tweak those. It also keeps track of zooming, so I'm going to play here again, and we can look at what zooming the map looks like. And it's still keeping track of that camera because I have it selected, so let me turn that off. So whichever map I'm on, I can zoom in on it and then I can pan around. Now all of that lives in that camera acting blueprint. So again, it's keeping track right up here. When you zoom in, again, there's variables that we can adjust on a per map basis on how much we want to zoom in. Here it's listening for the inputs and checking variables to see if it can move around. One of the challenges we ran into, obviously when you give player camera control with something like this, they're going to want to test its boundaries and drive off the map. So our solution for right now is when it gets a certain distance from its original point, it resets. And we did that originally, we tried just disabling the input, but then you'd get in a stuck state. And so now it just, when you try to drive it way too far away, it just resets. So let me jump out again here, and we're going to take a look at some of the construction of objects that allow us to have those real-time elements. And what I'm going to do is I'm going to open up my door. So here I've opened up my door, and obviously doors, that's the construction script. Here's my viewport. My door has a lot of different elements to it, but one of those is, I'll pop to it here, is this UI icon. And the UI icon, you can see it's at a Z value of 600. So if I fly up here, here's my door lock icon. And so in the construction script, what it does is it uses the default values that are placed in by the level artist of what floor this door is on, and then it teleports that icon to the correct location onto the map. It also updates the material on that icon based on whether it's locked or unlocked. And that all happens in real time. So all the level artist needs to do is drop this door in, set a single variable, and then the construction script and the event graph take care of everything else, so that the level artist doesn't need to do a lot of customization with the UI elements. We tried to set up all the various different elements so it's as simple as possible for the art team to just place content, and their adjustments are all controlled through construction script and blueprints. So another way that you can utilize real-world spaces in your level to create UI is an example of our equipment selection. Now this does have some traditional UI. These are widgets that we created that's an overlay, so you can choose your various different weapons and equipment. But again, if I jump out of my pawn, this is actually an actor that lives in the world. And he's in a little box. If I fly out of it, you'll see he's in this little dark box sitting outside the world. He's got some lighting on him. And what happens is the actor, if I open it up here, what's happening is the logic for actually selecting the weapon lives in the widget overlay, and the logic for assigning the weapon that he's holding and then finally assigning the final weapons that the squad will have live in this object. And if I come over here and look at his viewport, you'll see it's just a character and a camera. And we got his suppressor floating off over here for when we need to unhide it and attach it. One thing you'll notice is I have some weapons stacked up behind him. These weapons are set to no MIP, so when the player starts, the textures are forced to be streamed in. I actually destroy those as soon as the player comes into view, so that it's not using up any memory. And then this whole actor, once you leave the equipment screen, actually destroys itself, so it's not in memory while you're playing. Okay, the last thing I'd just like to talk about is the planning waypoints. What these are in the actual game is what I'm doing is when the player right-clicks onto the level, first I do a nav check to make sure that there's a valid nav point between his last point or his start point and the actual nav mesh. Then I cast out the required distance. Level 1 is negative 80,000 units, and I generate a spline between those two areas. And then along that spline, I generate static mesh actors to represent the arrows and the lines. So again, if I pop out here and I fly down and take a look around, you'll see that I'm generating these 3D objects along these splines. And how all the objects exist in 3D. And so that allows for relatively simple navigation. And because it's casting back to the main level, it uses the actual nav mesh, which allows me to check and stop players if they're trying to click on areas where the AI aren't going to be able to navigate to. Well, with that, I hope that gave you a nice overview of ways that you can use your levels to create user interface in different ways that can be interactive, other than just traditional UI methods. This was all created obviously in Unreal 4, and if you have any questions, you can check in with the UB4 forums. For support, you can always download Unreal 4 and play with it yourself. Thank you very much, and if you have time, check out www.cerealan.com, and our game Epsilon is at Epsilon the game on Twitter, and you can follow me on Twitter at Cerealan, Serellan. Epsilon is currently available on Steam Early Access in pre-alpha state. Currently, it's $7.99 US dollars, and that price will be updated when we add additional content and features in the future. So check it out.